Hey guys, it's David, BAC V RR. Hey, in this video, I've had a few people ask me, my signals and how I kind of work them. So I thought I'd just kind of give a basic overview on how I do my signals. So this is the WP portion of my layout on my CTC panel here. And it's pretty standard as far as how the switches work. This is your tortoise switch machine, normal, reverse. And these are for your signals, going left or right. So I decided to, well, this is my occupancy right here. Like in this particular control point, this is up there at Stockton Yard. And that's the west end of Stockton. So this tells me that there's a train occupying that control point. And the detector, it's just an optical detector, and it's actually right over the switch points, and I'll show that here in a second, that senses that. So these buttons here, well, this button I'm able to give a yellow or a clear signal. And initially I was just going to have all occupancy lights. That's why I drilled these holes. But I found that on my layout, I don't really need to, put occupancy in these locations because I'm sitting so close to the control points, I can see, whether or not there's a train on there. So I thought it was just kind of a waste. To do that, next button, well, this is my code button here. And it'll click a relay, and I'll show my schematic here in a second. And this button here is, say, if I want to take down the signal, which means revert it back to its red aspect, I just hit this button and it'll drop the relay. So my code button's right there. One thing about this design and the way I set it up is once you hit that code button, it'll clear it, but there's two ways for it to drop. Of course, one being just by hitting this button. The second one is by the train going over, and there is no way for that signal to go green again until I hit that code button, just the way I wired it up. So it's kind of a fail-safe system. It's not going to go green until I recode that button. So again, real simple system, and I'll go to the switch and show you here at, I'll go over here to East Midway. So pretty standard. You kind of see how I mounted the tortoise switch machine underneath, and I'll have to admit, you get creative when you mount tortoise switch machines as far as where to put them. So I ended up putting that there. Now this signal here, this is the LWP on the Altamont, Western Pacific. But this signal is more of a, it's shown up, I think, more of a yellow on camera, but it's more of a whitish lunar restricting signal. And all the signals on the Western Pacific, well, the majority of them, because the sidings were not bonded, you got a restricting signal to go in there. So there wasn't any detection in the sidings. So there's no reason for me to, well, put detection on the siding either. And I don't have any detection outside of my control points. So again, you saw the red light on the panel. And that's my only source of detection where it's at the control point. And I'll give you a close-up shot here. So you kind of see my sensor, it's right there. And again, it's an optical sensor through a Circuitron that I bought. So, and as you can see, I dropped the signal by putting the camera over it. So I'll reset it again and show you. So I reset that, and again, train's coming along here, and it just goes over, and you can see that the relay click there. You can't really hear it on camera, but I've got a couple of relays that'll throw there. And again, that's one drawback is you put any, you move your hand or whatever over the that'll drop the signal. So this is 5 feet above the ground, so there's really not an issue with that. The other problem with it, and in particular this one, that's kind of why I'm showing you this, is that I have lighting, or I have windows. So the lighting does affect it a little bit because it's, it'll change. You get a real sunny day, it may affect this. I got it set pretty well where it pretty much doesn't doesn't affect it. But, you know, if you got windows in here, you know, you got a sunny day versus a dark day, even though you got lights, fluorescent lights in here, it can screw it up too. So that's a second drawback. So maybe infrareds. I haven't tried infrareds, but maybe that's a reason they might be better for this application. But they work good for me. So, and I'll show you my schematic here. So here's my schematic I do. Now for each control point, well, Midway, East and West Midway are the same. But I'll come up with a schematic for all my different control points. So this happens to be for East Midway. And I took, in high school, I took a basic electronics class, and then in college I took just one basic electronics class too to help me with this kind of stuff. So again, this is a simple circuit here, and I'll go over it just real quickly. I'm not going to go over it in detail because you can kind of see what's going on here. But here's my switch on the panel, my normal reverse switch here. Disregard that, that's not wired in. And here's my two buttons. There's my code button right there, and there's my other one. This one's normally closed, and the NO stands for normally open button for the code button. So basically what it does is power is always going through here, and it's keeping that relay energized. So this is you can see this is a large relay here that I've got set up. So two things that are going to knock that down as soon as I knock that signal down, it'll turn it red. I just push that button here, and that kills that relay. So that all these switches are going to throw over. So that's a relay. And the other thing that's going to kill it too is if a train goes over it. So here's I use a DT-4. I've got 4 sensors on it. That's why the 4. And so it's always energized too, and it goes through a relay, comes out. And as soon as the train goes over that light sensor, that optical sensor, that relay is going to knock down, which throws this and throws my signal to red. You kind of see, I'm not going to go over all this, but this is all the signals. There's 3 signals at East Midway. This is coming out, main line, the siding, if I got that correct, and going the opposite direction. So that's just a basic schematic as far as what I do. But again, I do that for everyone. Now my light-its, that's a different story. Again, I just use a relay, a big relay bank here. So all the power is going in through the light-it wires are going into the relay. But as soon as that relay drops, then it bypasses all that, and the signal just dropped to red. So, but I have to manually set the signal. If I want to flash in yellow, I gotta set that. But then the optical sensor, once you go to the optical sensor, it'll automatically drop that signal to red. So it's basic, but it's functional. And I don't know what else to tell you, but that's about it. Oh, I'll show you this for the heck of it. In college down in Southern California, I actually drew this I was probably mid-80s. And I went out and I measured a signal just for the heck of it. So if you're ever curious as to how tall a signal is, this is kind of somewhat of a standard signal on the SP 14F. I think it says, for whatever reason, I've got inches there, but it's 14.5 feet. And let's see here. Kind of read the rest there. It's 44 inches, 131 inches between that point. And the bottom of the box, there's an electrical box here. And one thing, if you've ever seen inside, it's kind of neat how this works, but it also works similar to a relay. It's an electromagnetic inside here, so that signal, if it's not energized, or that electromagnet is not energized, that signal will be red. So it's completely fail-safe, and it's got a red lens kind of in the middle, and then green and yellow on each side. So if it's energized, it'll give either a green or yellow, depending on, it goes through a number of relays to get through that. But if it loses power for whatever reason, that signal's going to drop to red. So it's fascinating how it works inside there. And I was going to say one other thing about my dispatch panel. nice thing about this panel is I set it up so that I can just walk around and I can access it via the other side too. So let's see if I can get this thing in focus, which I can't seem to do here. There we go. Sorry about that. And yeah, that's about it, guys. So this signal bridge, this is functioning here. Other thing, just the basic tortoise switch machines, and then I use the NC switch 8s to control them with my my ProCab, my handheld wireless ProCab. So on the other side, I'll show you the other side, the other signals. So these signals, I have not wired these up, other than I just wired them all up for red aspect here. And the reason being is I can wire these in, but I'm kind of holding out. I want to get the Atlas BLMA signal bridge, and obviously they're not manufacturing right now, but I'm kind of holding out for that to replace it with that signal bridge, as well as a number of other control points I want to set up with new signals, and I'm just holding out for that. And of course, these signals here, this is a newer portion that I redid on my layout here. I've got to get in. They have older LEDs in here, and I've got to redo the LEDs first and tie everything in, so obviously nothing's lit up in this area. And then further down the line here at Fremont, I'll show you that. Anyways, I appreciate you guys watching. Just basic stuff on my signals here at the east end of Fremont. And again, this one's functioning, so as soon as it goes over the points, that signal dropped to red like it did there. So that's pretty much it. That's how this works. Simple system. Anyways, thanks for watching, you guys. I appreciate it. Leaving you at Lake LG, David, BAC 5. Signing out.